busy day today. Starting, I'm going to send out an email reminder to everybody. Starting Monday at 7:30, I'll no distractions. Again, if you're running late, that happens. You can watch the live stream on your computer or your phone, so you're not going to be missing anything. But it doesn't get in the way of the way my crazy brain is trying to process. All right, I think it's going to be an awesome day today. We got a lot of things to go over, but hopefully my job is to make it all kind of make sense. Local and global references. Easiest way to explain where we're headed. If one of you guys was facing me and we were staring at each other, and I said, on the count of three, point to the front of class. We go 1, 2, 3. We would both point in the same direction globally. But technically, I'm using my left hand. They would be using their right hand. So it's not exactly the same locally from our perspective, okay? So locally referenced things, such as joint motions, have to be from the joint's perspective. One of the reasons that this gets kind of confusing is because a lot of things in life are from global perspectives that we're used to. I have a couple examples that I'm going to illustrate to show you what local is by showing you what it is not. It was cold this week, right? So wrapping pipes and putting boxes on. There is a joint on this faucet, an articulation of two moving pieces or rigid links, right? You have the actual faucet and you have the little knob. And we know that movement, joint motion, lefty-loosey is going to open the water and righty-tighty is going to close the water. And that's what it's going to be for all perspectives. For it to be different, the house would have to move about the body. That's not going to happen. When I was at Auburn, the engineers that I had class with hated biomechanics, human movement, because in their world, this always stayed fixed and that always moved. The wall always stays fixed and the doors always move. But in biomechanics, I can move the door, but I can also move the wall. See what I'm saying? You can see how it could get confusing, right? Okay. So that's a global reference. Another one I want to kind of segue to is a double door. We have double doors here at Bourgeois. Think about it. Both of the doors, if there was an emergency and we were trying to get out as fast as we can and we pushed open both doors, well, there's a joint motion, open, and the other motion is closed. Flexion, extension, lefty-loosey, righty-tighty, you get, right? Two different ways to spin. But technically, those doors are rotating in opposite global directions, right? One's going clockwise, counterclockwise, like they're not like windshield wipers is what I'm trying to say. They're rotating in opposite global directions, but they're called the same motion. Open, closed, because it's relative to the actual door, not relative to the world. So what we're going to see is we're going to have joint motions that look like they're rotating opposite globally, but they're rotating the same locally. Does that make sense? That's why this is not the same motion, even though it looks like they're spinning the same from the room's perspective. It's not about the room. It's about you, and it's about your individual joints. Okay? Let's do some more examples of application before we move forward. Okay? All right. Clock. Love clock analogies. Clock's up on the wall. We have a joint. We have an articulation of segments. Clock hand is one segment. The actual clock is the other. Kind of like my hip would be the clock hand and my pelvis would be the clock. Okay? Watch this, how cool. We always see motion like this. That's how we tell time, right? Time move. But what would happen if I move both the clock hand and the clock? No time would have passed. Does that make sense? So even though we might have seen motion, there was no passage of time. There was no motion in the clock. Example of this would be Here's the clock hand, right? Here's the clock. What happens if I did this? That joint didn't move at all. Does that make sense? Just because the leg looked like it did something doesn't mean the hip joint moved. See what I'm getting at? We don't assume. We have to look at things relative and not just look at it globally. We actually can't look at it globally. What about this? I go from 6 to 9. I rotate it clockwise. I'm going somewhere with this, y'all. Like, this dude is Sesame Street. Today's lecture is brought to you by the number 4 and the letter G. This is where it gets a little tricky. But I'm hoping that I'm setting this up where it won't be tricky. Clockwise. Check this out. Clockwise. I'll do it again. Started on 6, right? Ended on 9. Now that's traditional clockwise. But here's the key. I started at 6. I ended at 9. Started on 6. Ended at 9. Globally, you saw 2 different spins. But locally, from the clock's perspective, I started and ended in the exact same place. So I had to have the exact same motion. Why do we kind of clockwise? Because 99.999% of the time, the little piece will always move about the bigger piece. The door will always move about the wall. But in biomechanics, we can move bigger pieces about smaller pieces, but they're going to look like they're in opposition. Easy example. This is left hip external rotation. This is also left hip external rotation. Because it got me to the same place. See what I did? So, for the clock analogy, clockwise, hip flexion. Simple enough. Clockwise, hip flexion. Got to the same place. See what I did? Think of it like this. If you were playing a board game, okay? I posted a meme the other day that a wife says, hey, let's play family game, yay. 2 hours later, the cops is like, we're gonna have to take a statement from everybody because those family games get intense, right? This may sound weird, and it is weird if you're playing a board game, but it's not weird when we're talking about human body movement. Everybody starts on go, playing Monopoly. You roll the dice, it says go forward 5 spaces. If you can get this analogy, you will do very well in any field you do. Move 5 spaces. 1, 2, 3, 4, 5. I went forward 5 spaces. But you know what else technically would move me forward 5 spaces? If I kept my little person still and I shifted the board backwards 5 spaces, I'd get to the same place. Move forward. 1, 2, 3, 4, 5. Move forward. 1, 2, 3, 4, 5. I get to the exact same place. So even though you saw 2 different global motions, you saw the same local motion. The person relative to the board changed the exact same. Okay? Makes sense? So, this example of the clock shows 2 important illusions of motion. It looks like it's moving. Hey, how are you?
How are you?
I'm doing great. It looks like it's moving, but it's not. Does everybody understand what I mean by that? It looks like it's moving, and it's not. The right hip looks like it's moving because you may say, well, the leg went back. But it didn't. It's still in the exact same place as when it started. A lot of times, it's going to look like something is moving, but it didn't, because joint motion is relative to that joint, not relative to a room. The other main illusion is it looks like it's not moving, but it is. That's this illusion. This hip moved, even though you didn't see the leg, you didn't see the clock hand move. The clock hand stayed still, but time passed because the clock moved about the clock hand. Does that make sense? Okay. So that's what I mean by perspective. It's from the joint's perspective. I am not going to teach you joint motion based off of specific angles. And I'm going to tell you why. Because, one, angles depend. If I'm decreasing this angle, I'm automatically increasing this one. Anytime you have one segment move, so you have to be very specific to which angle we're talking about. And we don't live in robot world. So if you say wrist flexion is a decrease of the anterior angle, yeah, that's cool. But what happens if I pronate and now all of a sudden I flex back here? Some of you are going to think that's extension. And it goes into all the different joints. I'm going to teach you joint motion a lot simpler than that. Purpose. What is the purpose of these joint motions? You ever wonder why there's so many things that flex and extend? Right? There's a lot of flexions and extensions because they all have something in common. They give purpose. Okay? Anatomical position is a human body universal starting point. It's so that we can communicate position and motion. It's no different than if someone says you're trying to give directions to someone. Let's say you need a jump. I jumped Mr. Leon, one of the janitors, 78 years old, really, really cool dude. If you're trying to give someone directions to jump your car, they need to know where you're at, or you need to know where they're at to give them directions. Where are you at? Everything in terms of position and motion has to be relative to other things. You've seen this where maybe you're not driving, you're not paying attention, you're sleepy, and all of a sudden a bus starts moving and you feel you're going backwards. You ever had that feeling? Yeah. And then you catch yourself, like, whoa, what in the world? Because it was relative motion. Okay? So what anatomical position does for us, it gives us a universal starting point so that we can look at where are you at relative to something. I think I said this on Wednesday. Bro Bridge is only east if I put it relative to something. It's east of Lafayette, but it's west of Baton Rouge. So you can't just say this is flexed or extended. It has to be relative to something. And guess what? That something is anatomical. Now, anatomical position isn't all or none. What do I mean by that? In the NFL, you could have everybody where they're supposed to be for an offensive play, but one person may be past the line. That one person is out of position. But that doesn't mean everybody else was. One person may false start. That doesn't mean everybody else did. So what I mean is that, yes, anatomical position for all of the different players. Remember how I like to look at joints as the players? But if I move, we'll get to the shoulder in a little bit. If I flex my hip and my knee didn't change, my knee is still in anatomical position. My knee is still in its home, its starting point. Just because my hip moved doesn't mean other things have to move. If I do this, did my elbow move? Well, globally, but Joint motion is relative. My elbow stayed in its anatomical position. My wrist is still in its anatomical position. Just because one player isn't, doesn't mean everyone else is not as well. Does that make sense? That's important. Position, joint position is where are you at relative to anatomical. Joint motion is where are you traveling? How are you moving? Where are you going? The easiest analogy for this concept before I start applying it to human joint motions is Interstate 10. Lafayette is our anatomical, it's our home because that's where the university is. But I can be east of Lafayette, position-wise, but I could be traveling west on I-10. And y'all have zero problem with that. You do it all the time. I can be west of Lafayette, but be traveling east. You've got no problem with that. And I can be east traveling east, west traveling west. I can exit to tank up my car and be east of Lafayette and not be moving at all. My elderly parents, well, elderly, they're approaching 80 years old, and my mom just found out that she could track my father on her phone. It is annoying. I saw y'all stop. Y'all okay? Yeah, Mom, we just tanked up the car. Okay, just making sure y'all okay. So position, where are you at? Motion, where are you going? The biggest secret, in my opinion, to a majority of understanding joint motion, once again, is purpose. Not to get bogged down with angle changes, it's purpose. We know a lot about anatomical position, but there's also another famous position called fetal position. When you wake up after sleeping all night, odds are you're probably not waking up like this. Right? Odds are you're going to be waking up more kind of in a crouched fetal position. Fetal position is flexed. Flexion and extension are the roads to and from fetal. That's a huge secret that I wish I knew earlier. Flexion and extension are the motions to and from fetal position. Even easier, or hopefully it'll make it easier, it's sagittal plane from every joint that travels those roads perspective. The ones you will be accountable for the first test. And why is this important? So that we can practice position and motion before we get into the confusing ones. We have to be able to speak the language. Yes, ma'am. You're good. If you're going from anatomical to fetal position, you're traveling in the sagittal plane of each joint that's moving. And so flexion and extension is literally like east and west. But am I traveling to fetal? And I don't know, let's say fetal is, trying to think of a city on I-10 that starts with F. I'm thinking of Franklin, but that ain't on I-10. Flexion gets you in the fetal, extension gets you further away from fetal. That's the magic. Now, it's relative to the joint. So in anatomical position, my wrist, when it gets me more in the fetal, it's going to look like this. Follow the fingerprints. But when I pronate my radioulnar joint, flexion of my wrist is actually going to look like that. My wrist doesn't know the difference. If I had little googly eyes, the wrist is now just looking that way. It's doing the same thing. It doesn't understand the back of the room or the front of the room. The wrist is like flexion, extension, flexion, extension, flexion, extension, flexion, extension, flexion, extension. That's why this is flexion extension no matter what position I put it in globally. It doesn't matter. Because the elbow is like, I'm getting more in the fetal, I'm getting further away from fetal. These are the joints that I'm going to hold you accountable for, and we're going to practice the heck out of it on the first test. Notice ankle isn't on there. There's a reason, because your ankle has two different forms of fetal position. Fetal when you're standing and fetal when you're off the ground. So like when there's two different forms of getting in the fetal. If when you wake up in bed because your feet are off the ground, you're probably not going to be dorsal flex. You're going to be plantar flex. Or a gymnast doing spins is going to be plantar flex. So two different forms of fetal. We'll worry about that on exam 2. Your cervical vertebra can help get you in the fetal or get you further away from the fetal. Your trunk can help get you in the fetal or get you further away from the fetal. Your shoulder, ESPN has been lying to you all these years. This is shoulder flexion. When they say fully extended, the only thing fully extended is the elbow. And guess what? It was extended when you were down here. Okay? Look out! My shoulders are flexed when I get in the field. Look out! Felt like I was doing the mark. Elbow can get into a ball and out of the ball, in the fetal, out of fetal. Wrist, in the fetal, out of fetal. Hips, in the fetal. Think of it like this, ESPN. Hips and shoulders, the exact same joint. So if this is hip flexion and y'all have no problem with it, why wouldn't this be shoulder flexion? Okay. And your knees, you can knees in the fetal, out of fetal. Okay. So those are the ones you're going to be accountable for. Now let us talk. This is an important note. Look at that. Anatomical position is not universally extended. I'm going to give you some examples and explain why. There are some joints that in anatomical position, you're all the way at the end of the road. What I mean by that is Lafayette isn't really a good analogy for every joint in the body. Lafayette's a great analogy for our shoulder. Why? Because from Lafayette, I can travel east on I-10, or from Lafayette, I can travel west on I-10. I can rotate in either direction from anatomical position. But there are some joints that are not like that. My elbow, for example, when my elbow is in anatomical position, it's like being in Jacksonville, Florida. Like it's all the way at the end of I-10, and the only place it can travel is west. Okay? So just because the elbow is at the end of a road, just because my knee might be at the end of the road, my radioulnar joint eventually you're going to see is at the end of the road, doesn't mean every joint is. Anatomical, I could go this way, I could go that way. So flexion and extension isn't about getting to and from anatomical. Flexion extension is getting to and from fetal. Okay? So now that we have that part, we can get to position and motion. On the test, I'm going to ask you, where is this joint at? And I'll have pictures. And when I'm asking you, where are you at? That is relative to anatomical position. So where are you at? My wrist could be in anatomical. Oh, sweet, you're home. Like a GPS, bing. But if I'm more into fetal from anatomical, I am now in a flexed position. That's like saying, if Lafayette is home for a joint that can move in both directions, and I'm in Breaux Bridge, I am east of Lafayette. No problem. I am flexed. Well, how far are you east of Lafayette? Well, I'm in Breaux Bridge. I know roughly how many miles that is. I'm in Baton Rouge. I know roughly how many miles that is. That's why we have angles. I've flexed 10 degrees, 15 degrees, 20 degrees, 9 degrees. Right? That's where angles come into play in terms of how far are you flexed? How far did you travel down that road? In anatomical position from my wrist, I can be extended. If flexed is like east of Lafayette, well, extended would be like west of Lafayette. I could be in Crowley. I could be in Lake Charles, depending on how far down I go down that road. Makes sense? So if my wrist is in a flex position, all that means is that I'm more in fetal relative to anatomical. And if my wrist is in an extended position, that means I'm further away from fetal, even from anatomical. Because think about it, I'm further away from fetal position here than I was there. Does that make sense? Where are you at? Your position is based off of anatomical. Where are you going? How are you moving? And where are you at are not the same question. They are not the same thing. I can be extended and be flexing. Just think about it. I'm getting closer to fetal when I move this way, right? Eventually, I'm going to get there. I can be flexed, but be extending. That's okay as well. And I could be flexed and be flexing. I could be extended and be extending. That sounds complex, but it's not. You can be east and be traveling east. You could be east and be traveling west. And let's say you pass up Lafayette, you miss your exit. You're traveling home, you're traveling to anatomical position, and you miss your exit, no problem. I'm traveling, I'm flexing, I'm flexing, I'm flexing. I passed fetal and I keep flexing, I keep flexing, I keep flexing. I flexed to anatomical position and then I flexed from anatomical position. I traveled west to Lafayette and then I traveled west from Lafayette. Do you see the difference? And that visually tells you where you're at relative to anatomical. Let's see if I can show it on the screen. This would be flexion of my left hip from anatomical, extension of my left hip to anatomical, extension of my left hip from anatomical, flexion of my left hip to anatomical, flexion of my left hip from, extension to, extension from, flexion to, flexion from. You see, to gets me to anatomical, gets me home. From moves me away. But the words flexion and extension literally means, are you moving into a ball? Are you moving into fetal? Or are you moving further away from the ball? Are you moving further away from fetal? Okay? Any questions? We're going to practice this concept. But I think one of the biggest mistakes that past students have told me is, answer what I ask you. If I ask you, what is the position of the cervical vertebra? Position. She's flexed. Here's a better one. Here's a better one. A lot of books will have it's insinuatory. And one of the commandments is we do not assume. So if I just say, what's this? And someone says, oh, that's flexion. You seeing something that I'm not seeing? In other words, if my mom's stalking my father and she sees that he is in Roe Bridge, but she doesn't see movement. She just knows that she's east of home. But he could be traveling this way, or he could be traveling that way. Your position doesn't assume your motion. Your position, where are you at? Where is that joint at? Is just relative to anatomical. Your motion is where are you going. In other words, if I just gave a static picture, let me pull one up. God, I hate this word. Y'all are going to find out why. Find a good one. Yoink. 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 Ah, you web file. Copy. Yoink. All right. If I asked you on the test, what's the position of her knees? And some of you are like, may say flexion. And I'm like, that's interesting. What if she's not moving? Or what if she's bringing her legs up? Hey, that wouldn't be flexion. So it's a common mistake to want to say, to mistake the position for the motion is what I'm trying to get to. It's a common mistake for your instinct to want to say, oh, that's flexion. But we have no clue if she's going away from fetal or towards fetal. In fact, she's not moving at all. She's getting gagged. She's holding this position for the photo. There's no motion at all, I promise you. She's trying to maintain a position. So we can't assume that she's going up or going down, especially if she's not going anywhere. Does that make sense? So what can we say about this picture? Her knees are flexed. And if we wanted to be specific about where is she at, she's flexed, maybe 40 degrees or so. We can eyeball it, or we can get a goniometer and we can check it. But that's all the information we know. We don't assume. I don't know how she's moving. She's probably not moving at all. So how do we infer motion? What we perceive as motion is actually just a flip book of still pictures that our brain is just snapping like a high-speed camera. Okay? Y'all know what a flip book is? We don't literally see live. We see pictures. So the two ways you have enough information to infer motion on a picture is if I say, okay, from this position, from where her knees are at, she starts moving her knees back to anatomical position. Well, now you know, oh, she's not home, and then she starts to go home. She's in a flexed position. She would have to have extension to go back home, to go back to anatomical. Does that make sense? If I said, she starts in this position, she's holding this picture, holding this position for the photo, then all of a sudden she starts moving her knees away from anatomical position. Well, she's already not in anatomical position, but if she starts flexing, she's going to get further away from anatomical position, right? She's going to be more in fetal, which means less in anatomical. That's the first way we can infer motion. I give you a fixed picture, and I say she's going towards anatomical or further away from anatomical. The second way is before and after photos. So watch. God, these linear terms kill me. It's all right. So start, finish. I used to say things like from left to right, but that gets too confusing because the right shoulder, the left shoulder, the rights and lefts, and am I correct? And so the verbiage that I use now based on feedback is start, finish. Guys, that's no different than if you know you started in Mississippi. Y'all were traveling for the summer. You went to visit a grad school in Florida. You weren't driving, so you could take a nap, and you woke up and you're in Louisiana. You know you had to travel west. You didn't go across the globe. So the point is that if I start with my shoulders mostly in anatomical position, and I finish with my shoulders in a flexed position, doesn't it make sense that I had to have bilateral shoulder flexion to get there? Start, finish, no problem. I started in a flexed position, and I ended more in anatomical. I had to have extension to get there. This is going to be important for you guys clinically because you won't have fancy equipment. Maybe someone will, but the best piece of fancy equipment you can have is this. And being able to see position change and not get fooled by or check in range of motion and they lean their trunk to get their hand over their head and someone may be like, oh, full range of motion in the shoulder. We have to be able to see these illusions. We have to be able to see these illusions. And we have to be able to talk about it so that we can better understand. Position, where are you at? Motion, where are you going? Okay? So, let's do some practice. Flexion will get you in the fetal. And I told you the joints you're going to be accountable for your first test on the 31st. Picture on the top left, her cervical vertebra is flexed. How do I know? Because in anatomical position, it looks like this. And here, her chin's close to her chest, so she's more involved. She's more flexed. But that picture on the left doesn't tell me where she's moving unless I have more context. Such as, I go from the left picture to the right picture. I go from start to finish. Oh, okay, she started here, she ended there. The only way to get there is to travel down the road of extension. Well, the sagittal road, but the direction of motion is extension. She got further away from fetal. Her chin got further away from her chest. Makes sense? Right to left, if it went back the other way, then that would be flexion. We will practice next week verbiage such as, if we're going from left to right or start to finish, cervical, let me do it for the camera in case you guys watch. We're going to practice this type of verbiage. This is coming, but I'm introducing it to you. Cervical extension to anatomical, cervical extension from anatomical. See the difference? Cervical flexion from anatomical, cervical extension to anatomical, cervical extension from, cervical extension to. Why is that important? Because it gives you an idea where you're at. If all I did was say cervical extension and I didn't show you, whoa, you're talking to someone on the phone, you're talking to a colleague, and they say they have pain when they extend the cervical. What part of the range of motion, right? Oh, they have pain when they're in a flex position, and they have pain when they extend to anatomical. That tells you exactly where they're at. To, from, to anatomical, from anatomical. Okay? For the trunk doesn't move a lot. Flexion from, extension to, extension from, flexion to, flexion from, lots of froms and tos. I'm going to hit upon this later, but hyper is a word that gets our people so confused. Think about what hyper means, right? A hyperactive child, more energy than average. Hypertrophy, hyperventilation, like excessive. Hypermobility. So hyper can be any motion if it's more than what you allow for. In other words, you can have hyperflexion if you had flexion beyond your normal range of motion, just like you could have hyperextension. Does that make sense? So a hyperextended knee just means the knee extended beyond its normal road. But you could also have a hyperflexed knee. You could have a hyper anything. So a lot of times when students get confused, it's not your fault. People will teach you and you'll hear, this is flexion, this is extension, and this is hyperextension. Really? Why wouldn't this be extension, this be flexion, that's hyperflexion? It doesn't. Hyper is just excessive, beyond normal. That would, to me, it's a lot funner to look at, can't hold word. Right lateral, left lateral, hyper left lateral, like it's arbitrary, like it doesn't make sense. The clock spins clockwise and counterclockwise. We spin, flexion, extension, and if I go beyond, right, hyper, excessive. And even that's relevant. I have tight hamstrings, so hyperflexion for me might be normal range of motion for you. And that helps explain people that are contortionists, people that are super flexible. That's their normal range of motion. Might be hyper for me, but it's normal for them. So let's look at some of these practice questions or application questions on page 18. Here's the wrist. Okay. Yes, the wrist. I'm going to teach you how the wrist moves in the frontal, but for the first test, it's all about practicing verbiage. Position and motion, to and from. We're going to go sagittal plane because you got a lot of different things that flex and extend because they're all trying to do something in common. Get you into a ball, get you in the fetal, get you out of fetal. Okay? So let's look at our wrist. In anatomical position, my wrist can get me in the fetal, we call that flexion. It can get me away from fetal, we call that extension. Anatomical position, I could have flexion from anatomical, but I could also have extension from anatomical. Cool? I can have flexion to anatomical, or I could have flexion from, I could have extension to, or I could have extension from. I can be in a flexed position and not be moving at all. It's just hanging out, it's flexed. When you're in a sling, your elbow's in a flexed position, but that doesn't mean you're flexioning. You're just flexed. Thank you. You're just in a flexed position. It's in fetal. Notice, once again, it's all relative to the joint. So if I had googly eyes on the front of my wrist, this is still the front of my wrist, even though it might look like it's the side now, because it's not about the room. It's not about, this is still the anterior part of my wrist. This is still the anterior part of my wrist. So from my wrist perspective, it doesn't matter what, the wrist doesn't, my left wrist doesn't care about anything else other than it. My left wrist is still in anatomical position, in other words. That make sense? So looking at the picture, flexion, extension, cool, but I want to teach you the next step. Flexion to anatomical, flexion from anatomical, extension to anatomical, extension from anatomical. Flexion to, flexion from, extension to, extension from. Any flexion, any motion that's flexion will get you closer to fetal. Even this got me closer to fetal. Think about it. I was in Houston, now I'm in Lake Charles, I'm closer to Lafayette, however what analogy you want to use. Flexion gets you closer to fetal. Extension gets you further away from fetal. From here to there, that got me further away from fetal. If this is fetal from my wrist, this is less fetal from my wrist. This is less fetal from my wrist. This is less fetal from my wrist. Extension gets you further away from the ball. Flexion gets you closer to the ball. Cool? This image, what's my position? I'm flexed. What's my position? I'm extended. From here to there, flexion. From here to there, extension. We have to have a reference. If all I did was ask you the position of the wrist, all I could say is it's flexed. No idea how it's moving, or it may not be moving at all. But if I say I started here and moved there, flexion. You see the context, how important context is? A lot of books don't have the context. They just get you assuming. And that's when you get into trouble. Start, finish, extension. But we have to have before and afters. We have to have references. Okay? So what I tried to do is I tried to put our verbiage into one nice, you can tell what I edited, right? So check it out. I'm in a flexed position, extension to anatomical, extension from anatomical. I'm in an extended position here. Flexion to anatomical, flexion from anatomical. I'm back to being in a flexed position. And if you're like, well, I'm flexed here and I'm extended there, what am I here? Anatomical. It's a position. The last bit of an analogy that I'm going to give you. We have a joint, a lid and a bottom, and we have motion, open and close. Most everybody is going to open by lefty-loosey. But what I need you to be able to see and understand, and it's not just about trusting me, it's about seeing that technically I can open up this container and make whatever content spill by actually rotating the bottle righty-tighty. That opened. Lefty-loosey, not if you move in the bigger piece, then it's actually lefty-tighty. Do you see what I'm getting at? Open is the small piece moving the way I'm used to, or the big piece spinning the opposite way. I'm still getting the same relative motions. Yes? And that is going to play big when we start looking at illusions. This is the exact same thing as this. This is the exact same thing as this. It's going to look weird. But just remember, if you know where you started and you know where you ended, you can figure out how you had to move to get there. Yes? Y'all have a good weekend.